5.4 is dividing polynomials. I'm going to show you how to divide polynomials by using the method synthetic division. So let's take a look at some examples. For this first one, it says 4x squared plus 23x minus 16, and we want to divide by x plus 5. So what we're going to do is we're going to take all these coefficients and we're going to write them down. So 4, 23, and negative 16. 4, 23, and negative 16. And then whatever we're dividing by, we're going to set that equal to 0 and solve for it. So x plus 5 equals 0. Solve for the x, and we get x equals negative 5. And this negative 5, we're going to put it up here in a box. Okay, and now how it works, we have our setup that we're going to make this line right here, skip a space in between, make a line, and then have room below it. We're going to drop this first number, so whatever that first number is, just bring it below the line, and then the diagonals, you're going to multiply them. So negative 5 times 4, we get negative 40, or negative 20, sorry. Put it in our next column. And then our columns, we're going to add them. So 23 minus 20, we get 3. So we add our columns, we multiply our diagonals. So negative 5 times 3 is negative 15. And then we add our columns. So negative 16 plus negative 15, we get negative 31. Then from here we have our answer. I know it doesn't look like much, but we're going to go through whatever this degree is. We're going to start with 1 less than that. So our degree would be 1. So it's going to be 4x. You don't need 4x to the first power, just 4x. And then plus 3. And then this last number is our remainder. So remainder negative 31. So let's try another one. We have 3x squared minus 29x plus 56. And we're going to divide by x minus 7. So we write our coefficients, 3, negative 29, and 56. And then we set whatever we're dividing by equal to 0. We solve for our x. So x minus 7 equals 0. We add our 7, so we get x equals 7. We put that in our box. And then we drop our first number to get us started. So we have 3. Multiply our diagonals, we get 21. Add our columns, we get negative 8. Multiply our diagonals, we get negative 56. Add our columns, we get 0. And then our degree is 2, so we start with 1 less than it, so 3x minus 8, and then this one has a remainder of 0. You can put remainder 0 or you don't need that. Now this next one is a good one to have in your notes. Notice how in standard form it goes x to the 5th, and then there's no x to the 4th or x to the 3rd or x to the 2nd or x to the 1st, and then it goes to negative 32. Now in order for synthetic division to work, we're going to have to put zeros as placeholders. So we know that that's not negative 32x to the 4th, and that this is x to the 5th power. So we're going to put 1, and then right here it should be x to the 4th, so we put a 0 there, x to the 3rd, put a 0 there, x to the 2nd, put a 0 there, x to the 1st, put a 0 there, and then negative 32. So each place value is accounted for. And then we go through the same process. So we drop that first number, our 1, multiply our diagonals, add our columns. Multiply our diagonals, add our columns. And we keep going through until we're done. And then this was x to the 5th power, so when we're writing our answer we start with 1 less than it. So it's going to be 1x to the 4th power plus 2x to the 3rd power plus 4x squared plus 8x plus 16, and then our remainder is 0. Now this next one, check to see if it skips any places. So it goes 3, 2, 1, 0. It doesn't skip any terms, so we can just put those numbers, 1, negative 14, 51, and negative 54. Then we're dividing by x plus 2, so we set that equal to 0. We get negative 2 for the box, and then we go through the same process. I'll give you some time to try this one and check your work. Make sure we're multiplying the diagonals, we're adding our columns. And then for our answer, it started out with x to the 3rd power, so we're going to start out with our degree 1 less than that. So 1x squared minus 16x squared, or 1x squared minus 16x plus 83, and then the remainder is negative 220. Right, this fifth example is x to the third power minus 57x plus 56, and we're going to divide by x minus 7. Notice how it skips a term. It goes from x cubed to negative 57x. It doesn't have that x squared, so think we need to put a 0 in that placeholder. So we're going to have 1, 0, negative 57, and then 56. And then we set this part that we're dividing by equal to 0. We solve for it. We get 7, so we put that in the box. And then we go through the same process. We drop that first number to get us started, and then multiply our diagonals, add our columns. Multiply our diagonals, add our columns. Multiply the diagonals, and then add our columns. And then we go through to write our answers, put the variables back in. So we start with the degree 1 less, so 1x squared plus 7x minus 8, and then the remainder is 0. And the last type of example we're going to go through, there's two different methods you can use. So it says evaluate a polynomial. So it says p of x equals x to the fifth minus 2x cubed minus x squared plus 2. And it says find p of 3. So they're telling us x equals 3. So one way we can do this, we can just plug in, if we know x equals 3, plug in 3 for all of our x's, use order of operations, and simplify it down. Or just type it into your calculator exactly like this, click enter, and we get 182. That would be our final answer. Now if we want to use the new method using this section, this 3, since x equals 3, we're going to plug that number right into our box. Now it doesn't give us an expression, so that's why we don't have to set it equal to 0 and solve for it. It's saying x equals 3, so put that number exactly in the box. And then it goes 5, it skips 4, so we need a 0 there. Negative 2, negative 1. It goes from x squared to 2, it skips the x term, so we need a 0 there, and then 2. Then we go through our process, we drop the 1, multiply with 3 times 1 is 3, add, we get 3, multiply 9, add, we get 7, multiply 21, add 20, multiply 60, add, we get 60, multiply, we get 180, and then add, we get 182. So then that is our answer. Whatever the remainder is would be our answer. And we get the same answer either way, so whatever method you would like to do, you can choose. Let's try one more of these. So we have p of x equals x to the fifth minus 3x to the fourth minus 28x to the third plus 5x plus 20. Then from here, they want to know what is p of negative 4. So with the first method, we could plug in negative 4 in for all of our x's. If you're going to use your calculator, make sure you plug that negative 4 into parentheses exactly how I have it written down so it knows to do the correct order of operations. When you click enter, you get 0. Now the other way you could do this, you're going to plug in negative 4 into your box. Use our synthetic division. Notice how it goes from x cubed, skips the x squared, and then goes to x. So right there we need to put a 0 for our placeholder. Then we go through and do the process, and this last number, our remainder, is our final answer.